what we have studied so far about the supply and demand. So if we press on the demand side, or as a supply side, so if we draw the demand curve and we draw the supply curve, I'm going to choose another color. If we draw the supply curve, you can see that this is the equilibrium price, this is the equilibrium quantity, right? Now let's say there was a shift in the demand, right? So something has happened, and therefore this would have increased somehow to this level. Then accordingly, this will be our new price. But this doesn't happen simultaneously or very quickly. Usually what happens in the market is that at that particular point, the companies will somehow still think that we are, they are going to be producing this amount of. So basically, here what we have witnessed is a drop in an increase in the demand side, right? So we can see that the companies would see that there is more demand than what has been actually supplied, and therefore they will start increasing their supply side. So they will start moving to this side, and they still found some some differences between how many people are demanding their product and how many they are supplying, until we reach this equilibrium point. This equilibrium point somehow is known as a steady state. So I'm going to call it double S, or the new equilibrium point. So if me and you just think about it. So let's say we have YT to be equal to YT minus 1. Like gamma YT minus 1. So I'm just gonna follow the notation of the book here. So they are asking you here, so let's say log cat, which is log food in our case, is gonna be YT, and we are adding YT minus 1, and we are multiplying it by gamma. So if we added gamma YT minus 1 plus, if we look at the main, so we have beta Q. So if we look at, so we have beta P, beta Q. So plus beta P, I'm gonna call it just for simplicity's sake PT. Okay, plus the error term epsilon T, or UT. So you can see that if as time goes by, we believe that what happened is to reach this steady state, then this means that YT and YT minus 1, once we reach this position or this point, what will happen then? There is no reason why the suppliers would want to supply more, or the demand would demand more. This was known as a steady state, where things are being steady. So this means that YT is equal to YT minus 1, and I'm gonna refer to this as a star, just to make sure that this is equal to Y star, which is the point at which things are in equilibrium. Okay, so this is Y star. So obviously, when this is the case, what will happen? We will have that Y star, which stands for YT star, is equal to gamma Y star plus beta P PT, or P steady state. Okay, plus error term, but the error term in this case is going to be 0, because there is no reason to deviate. And in this case, Y star would be, you can take the Y star to the other side, and then it becomes 1 minus gamma Y star is equal to beta P, the price at steady state, and therefore Y star is going to be beta P divided 1 minus gamma PSS. So now let's go back to read the question again. So the question is saying the following. If we go to question 6, a partial adjustment model. Add a lag dependent variable to the equation. The easiest way to do this is by adding log cat, which we thought about it as YT minus 1, as a type 2 variable, and set the lags to be scrolling back to 1. Note that the current value is indexed automatically. Consider how to interpret the equation if the coefficient on log cat minus 1, which is in our case log food, is going to be minus 1. Compare your estimate to those estimates with the elasticities obtained previously. So let's go through this in some steps. Okay, so I'm gonna open my TSM, which I call it as food. Okay, and I'm gonna be running the regression. So here what we do is we select log food as our dependent variable, the type 1 thing, type 1, we're gonna be running the log personal disposable personal income, the log p food, and the log q food. Okay, this stands for the main question that we were doing over here is this guy, right? So log food, log p food, and we have to include the intercept that stands for the beta node, and we're gonna look at p food, which is the price of food, q food, and this is a disposable income, DPI, and that was it. Now the question is asking you here, is telling you the following. You have to add also log food, but you have to add it for as a type 2, which is a dependent variable, log food. Okay, so they are adding you, and then they are telling you consider how to interpret this equation if the coefficient of the log cat, which is log food minus 1, is lambda. Compare your estimates. You have to compare the estimates to these numbers that you can see over here with the elasticities obtained previously. So you have to compare beta p over 1 minus lambda with beta p, beta q over 1 minus lambda with beta q, and beta y 1 minus lambda with the previous numbers, which is beta y. So if we hit the run, so now if we hit go, since we already have the regressors, the black variable, and we hit go, this is gonna be our estimate. This would be your gamma hat, the one with, this is gonna be your gamma hat. So what you have to do, basically, I'm not gonna do it over here, but because since you are gonna be graded for that, beta p, you have to find beta p hat, and you have to find gamma hat, and which we already have done that, and you have to compare this result with what you have obtained previously about your beta p hat. Okay, so and then you have to explain what do you think about this adding, which is adding this this lagged coefficient. Okay, and basically that is, and this is why an explanation why we think that we have to add a lagged variable. So it's up to you to agree or disagree, but you can see that according to us, we rejected the null hypothesis this is equal to 0, and therefore this means that this is significant, and therefore it influences the prices tomorrow are influenced by the prices of today, or the quantities that are demanded today, which I think is a very reasonable assumption, but it's up to you to think more deeply and write a certain report about that. So now the question is to do the Chow parameter stability test. Remember that this test, usually you have to classify or to divide your data into 2 samples. And you have to know if these 2 samples somehow originate from the same, they have the same parameters or different parameters. And if they are having different parameters, this means that we reject the null hypothesis, which is the data that there's something happened, right, during that, the difference between, between post the event and after the event. Okay, prior to the event and post to the event, which is after the event. To do this in our data sample, what we have to go is to go to TSM, to select, the dependent variable and the independent variables, and we have also to press on, the world test, but also we have to go to option forecasting. Oh, I forgot something very important here. So I have to go into the sample size, and I'm just gonna, because we have to split them into 50-50, so basically you can either select it to be 23 or 22, since we have only 45 data points, so 1 to 45. So if we divide 45 by 2, this turns out to be 22.5, which is 22.5, which is not we cannot divide half a data. So we're gonna either select 22 or 23. So let's say I would like to select our first sample to be from 1 to 22. And then what we have to do is we have to go to options, forecasting, and then we do the forecasting period is going to be to the remaining 23 data points, and this is going to be ex post, one step, and that is mainly it. We go to the linear regression and we hit go. So as you can see here, the Chow stability test turned out to be 0.011, which means that we reject the null hypothesis. And this is for how many variables, which is 4 variables, which you can see over here, right? So 1, 2, 3, 4. Okay, and that's mainly it. So it is less than 0.05, and therefore we reject the null hypothesis, which means that the parameters, it's not stable really, right? So the beta hat is different from one data point to the other data points. The last question, let the intercept of the model changes systematically with time. This means that we have to add a time variable. Okay, this effect is created by including the trend dummy variable, which is time t, and the variable t, which goes from 1 to up till n. To add a time trend, we just need to press on click trend, which is in the checkbox. So let's go to do this. So if you press on this linear equation, you will see that we still have the dependent variable, the independent variable, but rather than having only trend, we're going to be pressing on trend as well here. So the intercept, we're going to be pressing on trend. And we hit go. If we hit go, you can see that here is that our trend variable. This is our estimator, the coefficient, and we can see that this is much larger than 0.05, and therefore what do we conclude? We conclude that this coefficient is significant or insignificant? It's insignificant, meaning that this is somehow equal to 0. It doesn't affect with time. So the question continues to test its significance in your equation, and if it is significant, check whether the outcome, if any of your previous tests, depends upon it. So here you can see that because I chose food in my example, but in your homework you should select something different than food, which means that you have to be careful about if this trend turns out to be significant, because if it turns out to be significant, all your previous analogies or your previous analysis might be wrong because you haven't accounted for that trend. You may find that when the trend term is included in the model, the model collapses with nonsensical estimates. I haven't seen that yet, but you might encounter this. For example, your income elasticities could become negative. Okay, so you can see that some of the income elasticities become negative, right, which is p food. If so, this is likely be due to the problem of multicollinearity. There may not be enough independent variation in the variables to measure the elasticities effectively once the linear trend is taken into account. It is useful to know that this kind of thing is occurring because it shows that the data are not rich enough. That means that they do not vary to allow changes in the taste to be distinguished from the prices and or income effect. So in this case, we have finished your second assignment, and I hope you can write a good